Morning, ladies and gentlemen. I'm going to start in just 2 minutes, so just to give people a chance to come back in with their cups of tea and coffee, and a bottle of water for me. I'm going to start in 2 minutes.
Talk to his hand, yeah? Come for his hand.
Okay, good morning everybody. We've already had 2 live demonstrations this morning. We listened to feedback on previous MongoDB days, and one of the things we heard was we're seeing too many PowerPoints and not enough people actually doing something. So I thought I would bite the bullet and come out here and do you not just a live demonstration, but a live coding demonstration. They say, you know, never work with children, never work with animals, things can go wrong. How many people here, show of hands, I should say this is an interactive thing, so I will be asking you questions through the presentation. Please save yours for the end, the ones during the presentation are all me. So the first question is, show of hands, who has done a live software demonstration? Okay, that's a fair number, right. Keep your hands up, keep your hands up. Now, put your hands down if you've never had a live software demonstration go wrong on you. So, yeah, so we've got a couple of people here who either didn't get the question the right way around, or have managed to always do live software demonstrations perfectly, and to that, absolutely my congratulations. The rest of you who've had a software demo go wrong when you're giving it, please, a little sympathy for me today. As I say, it's not just anything else. I'm going to do some live coding during this, and it's also, as you'll see, it's going to be interactive, so there'll be some questions and some actions for you during the demo. The downside is I can't stand in front and do it because, well, I have to use the keyboard. So today's demonstration, I'm going to be using a language called processing. Hands up who has seen or used processing. Nice and high. Good, not very many. So just to give you a quick background, processing is Java for dummies. It's based on Java. It was designed for the visual arts community, so that people who were doing, you know, big interactive sculptures with lights and sound could do some programming for them without having to learn a real programming language. What it's turned out is a great way of showing kind of Java code without all of the boilerplate. It comes with its own IDE. Every program you run is called a sketch, fires up a window, you've got immediate graphics commands, sound commands, all of those things. So it's a nice way of demonstrating things. You might not choose to use it in production software. You probably wouldn't. So what I'd like to say today is this is MongoDB Days Munich 2014. My name, I know this one, is John Page, and importantly, my Twitter handle is John L. Page. I do appreciate tweets through this. We will be, in future, doing one of these things and pulling them live time for you. And I'm going to do an IoT demonstration in processing, so that's Internet of Things. So Internet of Things is basically it's about the vast amount of data that's coming in thick and fast to us today. IoT and big data go hand in hand. When you start getting small, simple data coming in from sensors, and it's coming in at tens of thousands of records per second, and you need to make sense of that, then sometimes you need some different strategies to the ones you might take for a slower moving data set. So, quick intro to processing. Processing, you kind of have two functions. You have a setup and a draw function. Speaking of IoT, if anyone's worked with Arduinos, it's very similar to the wiring language that they use. Your setup function runs once when you start, and your draw function runs an loop. It's as simple as that. So, code you want to run once, put in the setup, and then the stuff in the draw function just runs constantly. Think of it as single-threaded, really easy to get your head around. So I'll give you an example of that. In my setup function, I'm going to set size. I'm going to tell it I don't want it to smooth off any of the graphics, because by default it smooths pixels. I'm going to set background color. And these are all being called on the application objects, so basically on the background window. Buzz in my pocket there for a tweet, that's nice. I like the buzzy pockets, it means you're listening and actually tweeting along. And I'm just going to draw a couple of lines through that. Just give you an example of what this looks like, and also give you a basis for our UI for this application. So I've drawn one horizontally through the middle, one vertically through the middle. And we'll run that, fingers crossed. Crunch point, yes, we've got a window, 64480, 2 lines through it. Right, so what else can we do? Well, we'll put something in our draw function. What I'm going to do is during this presentation, we're going to be kind of graphing some sensor data, so I need a graph. So I'll just create some values. Again, those of you familiar with Java, this should be very familiar. Those of you not familiar with Java, it looks like any other programming language you've worked with. And draw a bar chart. I'll give it an X, a Y, a width, a height, and tell it to draw those values. Well, that fails. It fails because it says there's no function called draw bar chart in processing. And that's true. Processing has lots of very primitive graphics functions built in, and some not so primitive. You can say create a cube here, put a light here, create a 3D textured sphere, but it's not normally used for BI, so it doesn't know how to draw a bar chart. So my only choice is to write some code to draw a bar chart. Now I'll be a little bit quieter during this because I have to remember the numbers. But on a bar chart, X and Y position, width and height, and an array of values. I'm going to set fill to white and fill in the background with a white square, so I'm just going to clear the space. Then I'll work out how many pixels wide each bar is going to be, so the number of bars plus 1 divided by the width of the window. Work out how to scale them. I'm going to assume the values are 0 to 255 because that's what I'm using in the rest of the demo. And then for each bar, fill color based on bar height. Rectangle. This minus height thing's a bit weird. Processing coordinates work 0 at the top to something at the bottom, so I'm actually drawing a rectangle at the bottom with a negative height to make it go up. Let's do that and see what happens. Right, okay, bar chart. So just a kind of quick intro to processing, and also we've got the bar chart code now that we need to start processing some of our sensor data. So the next thing we're going to need, I guess, is some sensor data. So I spoke to marketing and I said, could you supply them all with a Bluetooth low energy 3-axis accelerometer? Did you get one of those at the door? Anyone get one? Yeah, that's because marketing said don't be silly. They said we're not going to do that. If you want to do it, come up with something else. So I looked into this and what the best way of getting sensor data was. And I came up with this. Basically what we did is we had the establishment fit photon emitters in the room. We fit some really nice fancy photon emitters, you can see them above you. And then we issued you with some passive opaque photon emitter devices. So you all got handed one out earlier. Can you all hold up your passive, it looks like an A3 piece of paper. Don't be fooled. There we go. So if you all hold that and you kind of angle it about right, what you can do is you can take, this is all quantum stuff, you take all those photons coming down, bounce them off your emitter device, they all come back towards me. So all I need now is a sensor. So I looked into photon detectors and I kind of bought one and it worked quite well, but there wasn't much granularity. But I found I can buy photon detectors in a matrix, quite small, buy them in a matrix. And then by putting a lens in front of that, I can actually get all of the photons kind of correlated by whether they're the front or the back or left or right of the audience. So I have this thing, kindly placed on a mic stand, which is a photon detector. You might know it as a webcam. Okay, now we might have to adjust this a little bit, but if you all hold up your bits of paper for me. Yeah. If you need more bits of paper, Jack has some down in the corner, so anybody that's missing a bit of paper, he'll pass them over. So the great thing about processing is that it has a library built into it. It's one of its kind of primitives for reading from webcams. So let's go ahead and use that. So you import processing video libraries, create a capture object, type webcam. You go into setup and tell it I want to capture from that webcam. Resolution, the name of the camera. I have multiple webcams on this. Tell it to start. So that basically turns on reading from the webcam. And then in my main function, I'm going to say if I've got a frame available, read the frame. It reads it into the webcam object itself, which is a subtype of image. So again, all nice and simple for the artists. So I'm going to run a filter on that. I'm going to filter out all the colours because you're all nice and coloured, but for the sake of my sanity, I'm going to work in black and white in this. And then call the image function, which is on the main window, to display the contents of the webcam. Right. The gods of demos are smiling on us today. You can all start interacting with my demo about now. Oh, look at that. You are actually all sending individual data to my laptop. The left-hand side, just put them down, the right-hand side, keep them up. And then you don't know which is left and right. Which is my left or your right? Let's go with this. So for future, it's from your point of view. That's left, that's right. Front, that's the guys nearest to me. Back's the ones not so near. Right, the other problem I have here is that if we're going to be looking at the pixels in this room, I can actually see the photon emitters directly up here, and they're going to really mess up the thing. So what I need to do is kind of zoom in a little bit. Again, processing is probably our friend here. I looked at some numbers in here that didn't work out earlier. What I'm going to do is just take the webcam object and copy a clip from part of it into the whole frame. So because it's a subtype of image, I can basically say take this bit and scale it to fit the whole frame. So let's try that and see if that's a bit better. There we go. So now it's zoomed in. Can you all hold up the paper again? Yeah, that's definitely making a significant difference to the overall picture. I would have given you much bigger pieces of paper, but then you hold them up and nobody can see anything. Right, from here on in, why have you got bits of paper? Well, the idea is that if you're liking the talk, and you think I'm saying something interesting, or I've said something interesting, first tweet about it. So obviously my pockets stopped buzzing, so people have stopped tweeting. That makes me sad. But also hold up your bit of paper, right? Because what this is an audience feedback detector. And the more feedback I get, the more kind of nice bits of paper that this registers, the happier I feel and the better the presentation gets, and the less likely I'm going to start crying and walk out. Sorry, am I speaking too fast? I realize I need to calm down. So the next thing I want to do is I want to put that data into MongoDB. So when we capture our sensor data for the webcam, and we're going to put it into MongoDB. Now, as I said, the nice thing about processing is that it's a subset of Java, and it's compatible with all the Java libraries, or at least most of the Java libraries. So I can use the standard MongoDB Java libraries from the MongoDB util. Create a Mongo client object, so again, anyone familiar with Java is going to recognize this code right off. I can just create those as nice global objects. Initialize a connection to my local host MongoDB. Catch the exception. This one I do have to catch the exception. For the sake of a clearer demo, I've cut out most of the error handling in this. Please forgive me. Get hold of a collection called readings on the demo object. And then I can go and fill in my update Mongo function. So I'll get the current time. Millis is the number of milliseconds since the code started, so I'll divide that by 1,000. And then I'll iterate through the pixels in the image. So my sensor data comes with 2 dimensions. It basically comes with a lefty-rightiness and a fronty-backiness, indicating where the information is coming from. Obviously, in a real-world IoT thing, it might be coming from different countries, different clients, different types of devices. So don't think of those as necessarily X and Y dimensions, it's just any dimension. Right, HTTP object on the timestamp, and then add the X coordinate, the Y coordinate, and the value. insert into the database, and that's us. So now what we're going to be doing is, you're going to be holding up your bits of paper, which you've stopped doing. Again, I don't know what's going on here. That's going to fire the photons from the lights onto the camera. We're going to record them, and every time there's some nice white values, we're going to put them into the database. Oh, GPUs take time to start. There we go. So we're running away there. Now let's see if we can see data going in MongoStack. Okay, MongoStack shows me that we are actually storing stuff in the database. We're actually throwing in approximately 10,000 readings per second. So it's a Mac, it's a single shard, it's not using Wild Tiger, but that's still not right. 10,000 readings per second, and just to let you know, there's not a locking thing here. Basically what's happening is I'm inserting those into the database one at a time. Each one I'm putting in, and then I'm calling again to check it's been inserted correctly. So that's not very quick. So, pop quiz. Who can tell me some ways of pushing that data into the database a little bit faster? There's at least 3 good answers I'm looking for.
Bulk inserts?
Bulk inserts, that's the one I really like, so we'll come back to that. Anyone know any others? Sorry, what was that? Right concern, yeah, drop the right concern to 0. So for this kind of sensor data, that might work quite well. You know, let's just throw it in and hope it goes in, rather than have to guarantee it. And the third one, slightly less obvious because I'm running in processing, is I'm only using one thread here. We could have had a few more threads kicked up. But bulk is a nice way of doing it. I'm going to do that just to show you how easy it is to move to a bulk insert model. So let me stop that and change my code to show you how much easier it is to do this with bulk inserts. So I need to create a bulk write operation. Readings.initialize unordered bulk operation. The reason I'm using unordered is unordered can rearrange things to work much nicer in a sharded system. It can actually optimize the pushes to the shards. And then instead of inserting straight to the database, I insert them into the bulk object. And then I call bulk.execute at the end of each frame. And that's it. That's all I need to do. And this should have upped our frame rate because we're able to handle a much higher rate of incoming sensors. Okay, so piece of paper. Only you can test the frame rate. I can't get it from the camera. Yeah, there we go. So that seems to be updating a bit better. And yeah, we're now getting 50,000 inserts per second. So for the sake of changing one line and adding 2, we've now quintupled the rate at which we're able to throw data into the database. Okay, so we've got the raw data going in there now. So the next thing we're going to do with this raw data is we need to turn that into a graph. What we're really doing is we're taking data that's got 4 dimensions. It's got back to front, left to right, a time, and a value of how much white is coming from that point at that time. And I'm going to change that down to being just into something that humans can appreciate, so a fewer number of dimensions. I'm going to do a timeline of what you think over time. So, as the talk gets better or worse, we should see that in the timeline. So what we're really doing when we're taking a bunch of data and dropping it down, display timeline, stop drawing that bar chart, display timeline function, is we're going to use aggregation. And we're going to use the MongoDB aggregation functionality. The aggregation pipeline absolutely rocks. One thing, when I'm working in Java, mostly I work in a nice Java OO manner and build things with Java. But I do like to write my aggregation pipelines in JavaScript. So what I tend to do is I write the aggregation pipelines in a shell. When I'm happy with what the parts are, I put the JavaScript into a string in Java and then use JSON parse. So rather than building up objects using the Java object builders and things, I can do this and basically create objects that way. It's a personal preference, but I just find it easier to do. So what this aggregation is going to do is it's going to group all of my values by the timestamp, and it's going to calculate O, which is going to be the average of the color. It doesn't care about X and Y, it's aggregating those out, and then it's going to sort them by the timestamp, which by now is in the ID. So I'll create values array, I'll run aggregation, readings.aggregate, aggregate, group and sort, and then because it's Java, I can just do for every object of the results. bullet value, which is going to be a double because that's the type that comes back from the aggregation. Cast it to an int because that's what I like to draw with. And draw a bar chart. X, Y, width, height, values. Alright, see if that works. So at this point, if we're lucky, keep the paper down just now. If we're lucky, we should be able to interact with our timeline. This is a nice steady timeline. Right, paper's up, let's see if we can make it go up. I had a little bit of a problem with automatic gain control of the webcam, so it's possibly turning all that down. So I'm gonna have to ask you to humour me in terms of that one, unless I can turn the automatic gain off. Let me check. No, it's all right. Okay, so hopefully pulling up bits of paper makes the graph go up. You get the idea for that one. What I am seeing over this is that little chart that's growing does seem to be getting slower and slower. So over time, I'm recording your interactions there. Hey, somebody wrote to me. And then it seems to be getting slower and slower and slower. And in fact, if I look at the log file for MongoDB, I'll see it's running aggregations, and it's taking 1,200 milliseconds or so. If I look at the insert rate into the database, obviously this is single-threaded, so the insert rate is going to be affected by the aggregation rate. I'll see I'm down at sort of 4,000. Where's that 50,000 number that we're looking at? Well, actually, it started off okay, and then it just went down and down and down and down. What's going on? Now my aggregations are taking longer and longer. Well, basically we're looking at a bit of basic computer science here. We're recording 5 to 10,000 new data points per second, and every time we calculate our graph, we're going and looking at the totality of previous data points. So we're going back, and this is an n-squared problem. If I stand here and talk to you for another 10 minutes, I'm going to be putting up one frame every 2 seconds. You know, we can't do that. We can't do what, to be honest, we see various people doing in MongoDB is they focus on how fast can I throw data into the database? How fast can I get it in? What's the load speed? And they push it in as fast as they can, and then they come to take it out, and they find that they've not really thought about how they're going to get it out of there. So their load is fine, but when they come to graph it, it just gets slower and slower and slower over time. So what do we need to do in order to be able to do kind of real-time feedback? Thank you, that's the first piece of genuine feedback I've had from somebody with their bit of paper there. What we need to do is we need to change this round. We need to think about what's our output going to look like as well as what's our input going to look like. And so what we're going to do is we're going to go and change it. So our update Mongo, instead of pushing those raw records into the database, what we're going to do is we're going to keep track of some summary information in there as well. So I'm not going to do an insert, I'm going to do an update. Big MongoDB lesson is updates are good. Inserts, hey, anyone can do inserts, but MongoDB's update functionality, that's something else. So what I'm going to do is I'm going to create an increment object, and I'm going to increment count by 1 and total by the color. So basically for each second, or each minute, no, each second, I am going to keep a track of what the total light value was, what the total of all the sensors was, and how many sensors I read. So basically, using the Java way of building the objects, what I've built is something that looks like this. Increment count by 1 and total by the color. And then I'm going to tell that to do it to a record based on the timestamp, where ID is the current time. So I'm going to find that, tell it to do an upsert, so it'll insert a new record if it's a new time. Do an update on that. Basically, find the record for the current second, and every time you get a new sensor reading, update the total number of sensor readings, or update the sensor readings added together. Now that looks like the frame rate's a bit better, and interestingly, MongoStat says I'm doing inserts and updates here. So inserts, I'm not sure why I'm doing the inserts. But my update rate seems to have gone up significantly. And so I need to then add in the code to yeah, hang on. I'm very embarrassing, but I am actually going to have to take a 1 second pause in the middle of this to fix something. Talk amongst yourselves, tweet how it all went horribly wrong. Yeah, let's take it. See how it goes. Okay, we're not getting a graph from that at the moment. We are getting a faster insert, right? But I need to update the graph as well, so that it actually shows me data based on that upstart information. So I find the data in the, now I have one record, at least theoretically I have one record. Let's hold off until we get it to work. It is going up just a little bit, but it is going up. Yeah, sorry about that, we'll delay that. It's actually a point out to do not source, so maybe some of that insert is actually the unsourced. So, as a final point of that, let's go and get a different dimension and display it. You know, we've been showing time versus total volume of votes. Well, let's go and see if we can show whether it's the front or the back of the room that hates me the most. So this time I'm going to do hotspot analysis. Again, I'm going to pull in my data. I'm going to have a new collection. And this introduces another concept that I quite like in MongoDB, the idea of a single record collection. The idea that you're using MongoDB as a persistent data store for a complex structure. But in this case, it's all going to go into a single record. What I'm going to keep basically is a running total for each pixel, for each seat in the room. So I'll update my hotspots collection and display it. So update hotspots is basically going to iterate through the X and Y. But instead of having a kind of updating a single record here, what I'm going to do is I'm going to update down into some nested objects within a record. So I'll get the Y coordinate, the X coordinate. Again, don't think in terms of X and Y, think in terms of the different dimensions that your sensor data has. Take the color from it. Create an increment object as I did before, because I'm going to update a total and a count. But this time, doing something slightly different. Instead of updating a top-level field, I'm saying update down 2 levels of hierarchy, total.x.y. Now, I'm not using arrays for this, as you might expect. What I'm doing is I'm doing nested objects. There's a couple of reasons for that, but mainly it means that if it wasn't coordinates that I was using, if it was customer and then customer server ID, the code would work the same way. So basically I'm doing an increment like that. I'm saying increment counts by X and Y, increment totals by X and Y. Then find the record with ID 1, so I'm finding just one record in the database. Maybe you timeline this as well. Maybe you take a new record every hour. But for this case, for this presentation, I'm just going to do that. And then the other part of this is I need to display that. So I've got one record in my database, I'll show you at the end, and it contains basically a running total for each of your seats. So find that record, create a new image, get hold of the counts object out of that record, get hold of the totals object out of that record, and then for each pixel, Y, for each pixel X, get the count values. I'm dereferencing down into the two objects to get it. Again, you know, if this were an array, I'd just be square brackets there, but it's better doing it as nested objects. There's no additional storage involved in that. I'm not using push. Calculate the average by dividing the count by the total. And then in the image I just created above, set the pixel color. And plot that image into a window a little bit to the side. So what I've done is I've gone and said, each pixel as it comes in, update the count for that pixel, and then pull all the pixels out per record, and display the average of them. As you can imagine, you could do this. You know, this is how do you pull sensor data in thick and fast during a short presentation like this. But equally, you could find yourself doing it, you know, over many, many days. Thank you. So, to the left-hand side of the audience, that's that side, I'll hold up your bits of paper. Right? Could my superfan in the audience please turn on her photon emission device, and we'll see if that shows up as a hotspot. Hopefully. So, you know, over time, yeah, even looking at that now, we can keep going. I can see that, yeah, keep them up, keep them up. There's definitely a stronger thing from the left-hand side. I'm thinking that probably about here is somebody who's kind of really into this. Thank you, Asio, with the torch. So that's how you take your sensor data in live time, it's streaming in, it's got multiple dimensions, and you boil down those dimensions and you store it. Unfortunately, I'm not getting quite the peak in the graph I'd like here. And yes, I'm ready to take the question.
Can you make it to show distance from the arrow?
Distance, yeah, so there's a lot of kind of clever math stuff I could have done. So I could have, for instance, snapshotted the room at the start and then diffed against the original image. So there was a lot I could do around manipulating the things to get better results. But it did make the code that little bit more complicated. And when I was trying to explain, okay, here's how I've allocated an object, snapshotted into that object, made a copy. Are you painting with light now, Ashley? Just drawing pictures. Heckling me with a torch, that's new. So yeah, I did that, but it just made for more complicated code when I was trying to explain it. Yeah. So you can do all of that. You know, the lesson here is don't store the raw data and then do the calculations later. Think about, wherever possible, aggregating as you go. MongoDB updates are just as fast as inserts. Look at timelines, look at breaking it down, look at keeping subtotals. This is the way we build the MongoDB MMS system, which handles billions of records per day, and it's how we advise you deal with anything that's going to be throwing in data thick and fast that you need to be able to pull up real-time graphs and statistics on. The last thing I did say I would do for you, potentially, is have a little look at what the database structure looks like in there. So I better not shut that down because that's the database. Okay, so I've got one record in hotspots and it basically looks like this. So these are my counts. So it's saying that at 59 front to back, 0 left to right, so I think that's probably Jack there. I've taken 23,909 readings from it, and somewhere I'm going to have a total in there as well of what those all added up to. But don't just think about X and Y, think about, you could have a structure like this, defining basically hierarchically every sensor that you have access to. And that's me. Thank you very much. If you do have any questions,
JP, John.